Hey, Steve Ostrowski with Trimble and the Building Point teams. I'm just going to do a quick unboxing of the new X9 Laser Scanner and FieldLink version 6.7, the software to run it. So as you can see here on my floor, there's the hard case that the X9 will ship in. It will also come with the backpack, similar to what the X7 came with, so you can actually carry and fly with just the backpack and the tablet, as well as the tripod legs that I usually actually put on the side here, and even put my computer in. T10X that will ship with the unit is also very important. This is where you're going to install through Trimble Installation Manager FieldLink, and then you can actually get the firmware from Trimble Installation Manager as well for the X7. You can see I've already taken it out, so not a real unboxing, but close enough. What comes with it, if you ever actually see it go red or it doesn't go through the calibration or it's been raining a bunch, you might want to wipe it off. I suggest carrying those as well as the cable. This helps with firmware, and if you are in a super busy Wi-Fi spot, this will help too. Also included are the certificate of compliance, starting guide, and then other accessory list that you may be interested in. One thing to note is the X9 is similar to the X7, the fact that it does a smart calibration or does a self-calibration routine before the scans. The X9 does a smart calibration though, so we'll see it actually calibrate before every scan. But after you scan 6 times, the internal temperature should be met, and then it'll actually only scan once every half hour, saving you about 30 seconds. It does look, and we'll bring it closer here in a second, similar to the X7. It does self-level to 3 seconds, and it does do that self-calibration, but everything else on the inside is new. It'll scan up to 150 meters away, so X7 was 80 meters. It's even farther. It will also have an increased sensitivity and increased accuracy. So the angular accuracy is actually 16 seconds now instead of 21, and it will collect a million points a second. Range noise is also improved to about 1.5 millimeters at 30 meters, less than 2.5 millimeters from before, and then better imaging as well too. So farther, faster, and improved speed are kind of where the scanner lies. So just a little bit better than the X7. The X7 is still probably leading scanning on the market for picking up most hard to read surfaces, dark and reflective, as well as workflow wise. But this scanner is going to be better. Now the workflow is going to be the same. It's still going to use FieldLink. You can still bring in a model or a PDF or register or resection it the same way. That'll all be the same, but the data is just going to be farther and faster. So let's jump into it, and we'll actually see from the perspective of the software what it looks like. So I'm going to use my my PC here just to share my screen on the recording. This again is all going to be handled the same way like it would be with the tablet. Connect to the device is going to be similar. I can actually, with the same tablet, connect to an RI, GPS receiver, whatever. If I want to do more layout, I can even lay out with the X9 or X7. But that's all those connections. So after I have that connection, I can kind of do a few other ththings. First thing I like to do is, or suggest is, with the SD card that does ship with it, it's a 32 gig. exFAT32, I can use a larger one. I'm just going to want to format it before I do that. That is usually what I would like to do first, is just format it if I'm reusing an SD card. I also like to set my Wi-Fi band. This just improves connection personally from my unit and tablet, as if I set it at 5 gigahertz, and so I can go a lot farther in between the scanner and the tablet. Those are kind of just the two things to get going after I have my FieldLink downloaded and the firmware, which obviously, because it's the first release, will be on the correct one. Going into collection, we're going to some scan settings. This is the improvement, right? So it's going to collect 27 million points and images in about 2.5 minutes. A minute of that is self-leveling and self-calibration. That self-calibration, again, is going to stop happening after the unit has reached an internal temperature unit. One thing I'm going to do before we get in here, though, is change this to feet rather than millimeters, so I know what I'm looking at. So the point spacing is going to be pretty tight, even on the low setting. This is typically, now because it's 27 million points instead of 12, enough points to register on an open deck. So the X9 is going to be ideal for larger environments, open deck, outdoor facade, things of that nature. The X7 is can actually still do those, but you'll obviously have to take longer or more scans. And both can be used interchangeably. You're just going to be a little bit faster with that one. And because this is 27 million points, I'm pretty confident that, and you'll see with my testing, that the registration is done well with that many. We're also going to do an area scan and show you how to essentially collect more points in a small contained region. Couple other things in here. So the image processing and images are a lot better. We're going to do fast every time is what I suggest, and automatic white balancing. I never change these settings ever because the images are actually very high quality. And then the speed, we have high or standard. You can see standard is going to go about 500 feet and high is going to be about 400 feet. So for the first scan, we'll just do high and low and hit start. So if you're familiar with the X7, you're going to know it's the industry leading in self-leveling. You can actually do floor flatness analysis. This is going to be the same level accuracy, but again, improved scanning accuracy. So it's going to turn around, do a little 180 self-level, and then shoot to its base to do that smart calibration, the first of about 6 before it's done every half hour. So with that, you see, if you're doing a ton of scanning, you will see a big time improvement with the X9. So after it's done with that calibration in the first minute, it'll start to spin around and collect scanning points for the fast, about 500,000 points a second. And then we're going to switch over and do a little range area scan just to show you what that looks like. So right about now, it's about done, and you're going to see just the speed with what it's going. Now, this is just the amount of points it's collecting. The accuracy of those points is still going to be incredibly good, especially at farther ranges or harder to read distances. So you see, I've had to open my window outside so that I can get something a little bit farther rather than scanning in my office here. Once it's done through about 50%, it's going to transfer the scan from the SD card on the unit to your tablet. And then on my tablet is where all that pre-registration. And then if I want to refine it and reference it to a model or coordinate system, that's what I'll do it to. So I can always grab the data back from the SD card later, but usually what I export out is directly from the tablet. After I collect scans, I can, and we'll do this first. We'll scan a couple. We'll do a registration, and then we'll also do a resection to some points we have. After I've done that, and I'm happy with the amount of scans I've collected and how I've referenced them to a model, I would export. Now I could export directly to RealWorks, FieldLink Office, Cloud Engine, or I can go directly to Autodesk and Navisworks, Revit, AutoCAD, or ReCAD, or I can go directly to Tekla. And so we have different file formats for each one of those. RCP for the recap or Autodesk formats, and TDX primarily for any Trimble software like Tekla, SketchUp, RealWorks, or FieldLink Office. So here you can see that first scan coming in. It's going to auto align. I can rotate or move that as I want. One thing to note is if I turn my layout points back on, you can see I have a couple points already in here. I can, if I want to, I can just align it to a 0, 0 point. And I would suggest if I have nothing else, if I don't have a PDF, that's usually what I like to start with, because then I know my floor elevation that I've created and I know where I'm coming in off of. So here you can see, I'm going to turn on the elevation so I know which points I'm looking at. This would be my 0, 0 point. I can very quickly just align this scan and actually the corner of this wall to that point. And one of the really nice things with FieldLink is the ability to change the center of rotation here by just hitting that little button in the bottom left and then zooming into the corner. I can see that I can align this up pretty well. Now, there is no residual check because there's not. It's just one point that I visually see. But this is still very accurate and something I can even do to a model. Rather than just doing it to the 0, 0 point, I can actually do it for a full model before I line it up. So you can see how easy and quick that is. This will actually set my scan so that my floor is near 0 and gives me a really good indication of where things are high and low. So rotating through to my elevation view, I can actually change it so you can see the ceiling. put this range on at about 1 inch. And so all I did was my floor is at 0, my ceiling's at 8 feet. You can actually see where it is essentially sloping back down from the window over and where that light is coming down. That's a great way to get started as far as placing just a coordinate system. And if I had a model, I'd do the same thing rather than just that 0 point. The other thing I can do is do a setup. Now, a setup is going to be just like a RI or RTS setup, except I can't do it over a known point. I have to do a resection. So if I have two known points and I can see them from one scan, I just go into setup like I would in RI or an RTS. It's going to level very quickly. And then if I scan before, I can actually use the scan image to drive the laser. If I don't, I actually have to manually move the laser pointer like I would with an RTS or an RI setup with just a DR setup. So here you can see we've done that. Move in here. You're going to see I actually have a target out here. This will be our first point for setup. Now, how I'm clicking here wouldn't be accurate enough. I'd actually want to walk out there close to it with my tablet to do this, but sometimes you just got to do what works for the presentation. So I would actually push that laser close to there, walk up close near it, and then use the joystick to really dial it in and even put it in turtle mode so it doesn't move that quickly. After I'm happy with the alignment, I have that point selected, I take a measurement. All this is going to do is a discrete point, so single point shot, just like a DR shot with any of those laser measurements, and then I would do that with the second control point. Now, pretty similar to like a GPS setup too, although a GPS setup is going to need to be outside. View the satellites and do 3 points or 4 instead of just 2 to resection. I would typically suggest using this setup in like smaller projects. If I wanted to cover an entire area, I may want to do a traditional georeferencing back in RealWorks, meaning I have controls spread throughout the project. I know their coordinates. I have a checkerboard like I do on my wall right here that I can extract and essentially use those as my setup and my georeferencing. So I've hit that point. I'm then going to click on it. I believe is that the one? I believe it is. We shall see soon. Hit measure again. And what you're going to see here is hopefully if I have good control, I'm able to drive that in. Measure it well. Now, one thing I forgot to do, it's going to be difficult to show you, but I'll show you on the other wall, is I'm actually close enough here to see where that's visually aligning. So once it's set up, we'll see what the position is, but that's what I would also want to do to kind of set it up. So it's still a pretty good setup, and I can set this and then align that last scan. And so you can see this scan has aligned to those 2 setups. Out here with my target, which we're going to collect actually a higher density here in a second. Now, collecting a point or using, if I turn it around to what you can probably see up here is John Glenn. If I point that laser up there, you're going to see it pop in. And then I would typically, to make it go very accurately, want to actually measure it in by just moving it like you see here. To that, and we'll put it on the wall just so you can kind of see very quickly. So that's an initial setup. I can we kind of cover 2 ways: manually move it to a model or a point, or I can resection. The third way would be to tag some coordinates or get them and traditionally georeference back in RealWorks. Now, one of the other big advantages we have with the recent releases of FieldLink is the supported area scan. So what this does is it allows me to collect high density in just a smaller area. So I can still be quick, still register together, but get that detail I need in these specific areas pretty quickly. So here I just did a rectangle scan around my target here. And I can do multiple area scans. I can have them all queued up. But this should definitely improve my speed of collection, and B, limit the amount of data. One of the things with scanning is we typically always collect a ton of points so that registration happens. With 30 million points, that registration should be good. But we also want some more detail. So what this allows me to do is capture very high detail very quickly and then not get a bunch of detail on walls or the ground that I don't necessarily care about. If I'm doing a ground or topo analysis, I still probably only need a point every couple inches anyway, so that's sometimes overkill as well too. So once this is collected, we'll take a look at the difference in data between the standard and low and why that's good, and the time speed you get from doing that. So you can see here it's going to transfer over, and then we'll turn it on. So from this perspective, we're going to go from a top-down view, and usually what I like to do is do a quick section box again. We'll actually include this, we'll include that tree, and then I'm going to extract out everything. So what this just did is I did the section box and then I extract out the full detail. When you're looking at FieldLink, we actually typically only show you a preview of the scan data. When you export, you get the full detail, but you can see here kind of the differences when you get, you can actually tell right away how many points you're getting on a surface and how good that looks, especially for that target there that we use to resection, and the difference between the low level and high level. And you can even see the distances as well too. So that's an area scan, as well as a resection setup, which is really nice. One other thing to note is if you like this section box tool, which I love, especially for scanning, it's good to do it from a top-down view where it'll actually automatically size. And then I use this to check my pre-registration. Now, a lot of manufacturers will do the pre-registration. FieldLink and Trimble are actually the only ones that will do the refinement, and FieldLink's the software that will actually register and compare back to my next point, which is how to align it with a scan. So here you can see I've resectioned to nominal control points. I actually have a model here, a Navisworks model, or no, it's a SketchUp model. I could bring in a Navisworks model if I had one, as well too, of my house here. We'll show you how to register that. So if I wanted to, because I'm set up, I could lay out, I could collect single points. I already have all that done though. So we're just going to go ahead and collect one more scan. I'm going to pick up the scanner and move it to show you how the pre-registration happens. And then move on. So pretty limited environment for where we're at. See, that's cleared the setup. And then I'm just going to hit start. I could tie this, the scanner has an IU on it, inertial measurement unit, which is how it knows where it's been, as long as it's been turned on. We have plenty of ways to manually register very quickly. This is just how we automatically register back to generally the last scan. But if I was coming back the next day and I'm on scan 100, but I'm overlapping with scan 56, I would just have to find that and click on the list as far as where to register to. Resection scans for us have bullseyes on them because we don't want you to move them. I feel like if you put the time into resection it, you probably don't want to just manually move it and clear that resection. So if you actually do want to do that but still use a scan, just delete it and then re-import it back in from the SD card by just going to More, Projects, Import, and then you can actually click it here when it's not scanning to bring that same, to go to the SD card from the tablet to bring it back in. But again, we don't want to just let move a resection scan. So we take our kind of protect it there. As this is collecting, once it's done, we'll let it pre-register back to 1, and then I'm going to show you how to manually align it and do a quick inspection. So a couple other things to note with FieldLink is the ability to bring in multiple or really any type of model. 2D or 3D. We love 3D because we can do a scan to model comparison to actually see if the as-built match design in the field. You can then take measurements between the real world and design, as well as send images and reports out from that. We have a lot of other videos showing you that with the X7. Again, similar workflow with the X7. You're just going to be farther and faster when you collect with the X9, and a little bit better accuracy. One thing I'm not sure if we covered before, but again, this is the same battery, and it'll ship with this. That works with the RTS and RI as well too. So again, after it reaches 50%, that's actually just 30 seconds of scanning there on that low level. It's going to transfer that over and then take some pictures. It's going to then try and register to whatever I have it listed here. And it will import that. So here's scan 1 near the window, scan 2 just came in. We can start to see differences in those scans just by turning that back on. Now, I probably should have created some control, or at least got the control measured into where the model is, but this is actually a good example of how to manually register some additional scans to fit where you're at. So I'm going to auto rotate this, and generally if I'm doing a large building, the automatic detection is kind of local to that scan. So I'll just manually move it in here. Turn it on the outline mode because I find that's easier to align with. And then start to align it this way. And some other things we like to do within FieldLink is I can turn off layers. So if I have a second floor like I do, I can turn that off so I'm not kind of bogged down with it. We'll get this wall very nicely aligned and we'll show you what that looks like. So pretty quick manual alignment. We'll turn off the previously registered scan because we're not using it. And we'll turn this one back on. And so what that did was rather than tying it back to that control there, let's jump back in here. We'll turn my unregistered scan back on. It tied it to that model. So I can actually see here scan and model, which I can turn on. I like to do this, turn it on with a blue scale or blue scale here to see the differences. So this is the scan aligned to the model. Again, this is very nice because I can actually see the differences between design versus as-built. Like you can see my wall has some pictures on it. If I come in here, I can actually see the deviation of those pictures from design and how that may affect what goes in later. So in the 3D view, you can see it here. I can just go to scan inspection and run an analysis over everything that's in this section box, and it'll colorize the distance from the scan to the model. Turn this off. Here you can see everything green is within 1 inch. I can actually bring that down in tolerance, so I can start to see the deviation of those pictures and where it was aligned. Bring that down to 1 inch even. So you can see I aligned essentially a little too far back, so the wall, when I realigned it, was a little bit to the north. So I'm going, or to the, I guess it would be the west. I'm going to re-register that, so it's probably a little bit better. And then make sure that I get the rotation right, which is also important. So to do that, a couple button clicks, bring that back down, undo it, and use my wheel to zoom in. Make sure I align that up. Now I would like to do this, or I like to do this on large projects because I can cover multiple scans to align a specific wall. Rerun my inspection, and then hopefully start to see that those images are bumping out a little bit. And here you can see that is the case, as well as the wall bowing too from the inside. So again, we saw improved speed, area scan, and improved accuracy and amount of points collected. The workflow as far as exporting is going to be the same. So I can do a very quick RCP export and bring both these in. Usually while this is good is I would want to or why this is really nice is I can send just that area if it's tied into the coordinate system. If I had multiple scans, again, Trimble's the only one that will do the refinement in the field as well too, so you can really go from tablet to CAD software. But looking what this looks like in Navisworks, I can just quickly open that up and bring in both the model and the scan data, which should align very well together because we're manually aligned there. So we'll wait for Navisworks to open up. We can append and bring in that file that we just exported. And so one of the things that may be a little bit difficult is so navigating to the correct IFC in the same coordinate system that the SketchUp model was from. We should be able to bring that in. If we find it here. IFC, there we go. And you can see it's aligned correctly when we're in there. And then I can do my same clash detection here if I wanted to, as well as just do my other coordination efforts. So directly exporting from FieldLink with a smaller section box to as an RCP or as an E57 if I want to go directly to Tekla. I can bring in, again, the TDX into SketchUp, RealWorks, Tekla, or FieldLink Office as well too. But very easy. Similar workflow for the X9 as for the X7, just farther, faster, more accurate. But yeah, please reach out to your nearest Building Point representative if you have any questions or want to see a comparison or just get it out there and use it. Thanks.